So today you're going to take some notes on section 4.4, isosceles triangles. And I have a document on Schoology that has these note frames already printed. So feel free to print out those sheets so you can take your notes on them. If you cannot print this worksheet, then make sure you draw out all diagrams carefully in your notes. So, parts of a triangle, parts of an isosceles triangle. This is review. We've already talked about isosceles triangles before in our triangle unit, but now we're going to see how we can use our knowledge of isosceles triangles within triangle proofs. So the parts of an isosceles triangle, we have legs. The legs are always congruent. And then we have our base. We have base angles that are congruent. And this angle up here is our vertex angle. Again, reminder of properties of isosceles triangles. So in an isosceles triangle, this segment AM is an altitude. So if we know that it's an altitude, we know it creates two right angles. So the angles that are congruent are AMC. It's congruent to angle AMB. Okay, and just note, it is an isosceles triangle, so I'm just going to mark those two sides congruent just so we know that we're looking at an isosceles triangle. We also know that segment AM is a bisector. We could also say AM is a median because it bisects the base. So we know that CM is congruent to BM. The third bullet point is something that we've spoken about before, but we've seen AM bisects angle CAB. And we may not have focused too much on this, but be aware that you have angle CAM congruent to angle BAM. Okay, so this will always happen, that vertex angle will always be bisected. And then also these base angles are congruent. So notice how this altitude, it splits this isosceles triangle up into two congruent triangles. We also have a reflexive side there. So if you notice, we have all the corresponding parts of these congruent triangles are congruent. So the triangles that are congruent are triangle CAM and triangle BAM. Remember, different ways you can write them, but we need to make sure that the vertex points match up to their corresponding parts. And the theorem that justifies this, we could use them all. We could use side, 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 angle, side, angle, side, angle. We could use angle, angle, side. We could use RHL. We could use them all because if you recognize we have this isosceles triangle with that altitude drawn, we have the reflexive side, congruent angles, congruent sides. Any postulate could justify these two triangles congruent. Triangle CAM and triangle BAM. So just a reminder with isosceles triangles, I would like for you all to pause and go through these examples just to make sure that you are reminding yourself of these properties. So this first one, we have a right isosceles triangle. So we know that x has to equal 45 degrees because those corner angles are congruent. Okay, for this second one, notice how we have two angles inside. Okay, we have two angles inside of this figure. So we have 63 and 54. And if we subtract those from 180, we are left with 63 degrees. So we have these two corner angles are congruent. So the sides that are congruent are the sides directly opposite. So we know that x equals 11. For the next one, we have two congruent angles. So I know that 18 equals 4x minus 6. And x equals 6. And then for the last one, we have these two congruent sides. So you know, okay, this angle must be congruent to that angle. So both of those angles are x. So if we do 180 minus 74 in our calculator, we get 106. And then we can divide that by 2 to then get what each of those angles are. So we can say that x equals 53 degrees. Okay, so this is practice. This is a review of isosceles triangles and working with those diagrams. So a reminder of the isosceles triangle theorem, which we abbreviate as ITT. That states that if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So if AC is congruent to AB, then which angles must be congruent? Think about it. Angle B and angle C. So the isosceles triangle theorem, when you're looking at that, you're given information about the sides. And then if you know the sides, then you can prove that the angles, the base angles, are congruent. So this goes from sides, knowing about the sides, to knowing about the angles. We also have an isosceles triangle theorem converse. And what would happen there with a converse theorem? What are we doing to the hypothesis and the conclusion? Hypothesis and conclusion will switch. Okay, so if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So I'm gonna, sorry, I skipped that last problem. I'm gonna fill this in and then I'm gonna go back to that last slide. So if we know that angle C is congruent to angle B, then we know that AB is congruent to AC. So we know information, we're given information about the angles. And then we can prove stuff about the sides. So you know stuff about the angles, we can prove stuff about the sides, and this is the ITT converse theorem, ITTC. Okay, ITT converse, isosceles triangle theorem converse. Okay, so we've seen these theorems before, but now let's see what they look like in proofs, or why, I should say, these are theorems. So remember, theorems can be proven. So we're going to prove the isosceles triangle theorem. So I have AB congruent to AC, and we know that AM bisects BC. That's our given. Okay. We don't have AM in the diagram, so please draw that in, and M is down here. So right now we have to go into this proof not knowing anything about isosceles triangles, right? We're trying to prove that angle B is congruent to angle C. We're trying to prove. So once I mark up my diagram, okay, we get this. Now, from our given, we know that AM bisects BC. So if AM bisects BC, then what pieces are congruent? BM must be congruent to CM. And this is the definition of a segment bisector. Okay, so we're trying to prove angle B is congruent to angle C. Can we prove that these two triangles are congruent? We recognize we also have a reflexive side. So triangle ABM is congruent to triangle ACM through side, side, side. Now that we know that these triangles are congruent, we can prove that angle B is congruent to angle C through CP, CT, C, CP, CTC. There you go. So through our knowledge of congruent figures, through our knowledge of congruent triangles, we can prove this isosceles triangle theorem, showing that the two sides of a triangle are congruent, then the base angles are congruent. So this is a proof of this theorem. But when we begin using this in other proofs, we are just going to jump directly from step 1 to step 5 and use the reason of ITT, Isosceles triangle theorem. So ITTC, let's look at the proof of that. Okay, this is the converse theorem. So again, we have our given. We have angle R is congruent to angle S, and we know that PM bisects angle RPS. Angle R is congruent to angle S. Okay. All right. So in this diagram, we cannot assume that this is an isosceles triangle. We want to go with what we have in our given and then try and prove that segment PR is congruent to segment PS. So notice here we have PM bisects angle RPS. So PM bisects angle RPS, then what do we know? We know that this angle is congruent to that angle. So we know that angle RPM is congruent to angle SPM through the definition of an angle bisector. What other bit of information could we conclude from this diagram? Notice how we have a reflexive property again. PM congruent to PM. Is that enough information to prove these triangles are congruent? Yes. So through what reason? Angle, side. And now we could say PR is congruent to PS through CP, okay? So these are the theorems, okay? These are theorems. Theorems can be proven, which is why I'm showing us these proofs. But as we use these theorems within future proofs, we can just skip this, all of the work that we did here and just write isosceles triangle theorem converse. Okay, so let's look at an example of how we can use these theorems in proofs. So I'm going to write down the given, and I want you to as well. M is the midpoint of segment JK. That's our given. So if M and also angle 1 is congruent to angle 2. Okay, we want to prove that JG is congruent to MK. All right, so here's JG and here's MK. So we want to prove those two pieces are congruent. So from our given, if we know that M is the midpoint of JK, then what do we know? I know that JM must be congruent to MK. And the reason why, think about the key word in the given, it's the definition of a midpoint. Okay. And we also from our given know that angle 1 is congruent to angle 2. So since we know that angle 1 is congruent to angle 2, we have information about base angles. Can we conclude that the sides, we have information about base angles. Can we conclude that the sides opposite those angles are congruent? We sure can. So here we know that JG must be congruent to JM. And that is through the ITT converse theorem, ITTC. So remember, if we know stuff about the corner angles, then we can prove that the sides opposite are congruent, and that is our converse theorem. Okay, so this is different. Notice how we have JM is congruent to MK, but JM is also congruent to JG. And we want to prove that JG is congruent to MK. So is JG congruent to MK? It is, and it's congruent through the transitive property. Okay. Also, notice here how we have a single triangle. We have a single triangle and we are lacking another triangle. Please do not see a triangle and automatically assume that you are completing the proof through side, 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 angle, side, angle. Because remember, those are methods to prove whether two triangles are congruent. But here we have a singular triangle, so we know we won't be including those postulates in our proof. Okay, let's look at another one. Let's look at our given. Let me write that down and then we can mark the diagram. So if we have AB congruent to AD and angle C is congruent to angle 5 and angle E is congruent to angle 6, right? That's our given. So look at the diagram. How many triangles do we have here? Okay, we have two triangles. But notice how the triangles are kind of overlapping. We can trust our eyes in this diagram to show one of the triangles is definitely smaller than the other. So we're not proving these triangles congruent, but we can use our knowledge of triangles to help us. So if I have AB and AD are congruent, okay, let's address one bit of the proof at a time, okay? And then we know that angle C is congruent to angle 5 and angle E is congruent to angle 6. Okay. We want to prove that these bigger sides, AE, is congruent to AC. All right, so I'm going to erase a bit of the problem so that we can see the diagram a bit clearer. Okay, if we know that AB is congruent to AD, then what can we conclude? Remember, we have two triangles here, AD and AB. But AD and AB are sides of a triangle, and the triangle that they are a part of are A, B, D. So what angles in this triangle will be congruent? I know that angle 5 must be congruent to angle 6 because of the Isosceles triangle theorem. Okay, so we've checked that off our list. Now, angle C is congruent to angle 5, so I give that a single tick mark. And angle E is congruent to angle 6. 6 has a single tick mark, so does E. So what can we say about angle C and angle E? They are congruent through the transitive property. Okay, and since those are congruent, now we can prove that the sides opposite those angles are congruent. And since we know that the angles are congruent, we're trying to prove that the sides opposite are congruent. Angles to sides is ITT converse, or ITTC. Okay, so notice how this is a short proof, right? It's only 4 steps, 3 steps plus the given. And we're using both the isosceles triangle theorem, ITT, and the converse of the isosceles triangle theorem, ITTC. Okay, let's try one more proof. And I want you to pause the video and I want you to try this one on your own. So we have xy is congruent to xz. Try this on your own. Go. So knowing that xy and xz are congruent, I can prove that angle 3 is congruent to angle 4 because it's an isosceles triangle. And we can use ITT. Okay. We also can prove that angle 4 and 5 are congruent through the vertical angles theorem. And our last statement, angle 3 is congruent to angle 5, if you notice, angle 3 is congruent to angle 4, but then angle 4 is congruent to angle 5. So we can say that these two angles, 3 and 5, are congruent through the transitive property. will be practicing more proofs like this when we get to class next time. And we will go through any questions that you have. This will take a bit of time to get used to, but we will address them and have more